right, that's good enough. All right, guys. So this last bit, number 3, who had, well, let's see. Who feels like they were able to do these problems pretty well? Number 3. Okay. I appreciate the honesty. So let's do this. I want to kind of today, the bulk of today is going to be talking about factoring, because factoring is one of the most important things in like algebra-based mathematics. Come on, you guys. Did you see any? You saw the map, I guess.
Yeah.
Okay, good. All right, so it works. Good. Okay. Here, maybe lower this dude. Lower Jeff. Okay. So let's do this. I want to show you something kind of cool that I don't think a lot of teachers show students. Would everybody agree with me that factoring expressions is pretty abstract? Like, compared to like, if I ask you to factor, give me one way to factor 42, for example. 7 times 6, right? So that's pretty concrete, right? Is that fully factored? No. But it is one way to factor it. If you want to fully factor it, what would you do? Why is it not fully factored?
Oh, because 6.
6, yeah, so 7 times 3 times 2, blah, 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 right? All right, cool. So that's what you call prime factorization. You factor it until you get nothing but primes. Everybody with me? That's definitely old news, right? The new stuff is when I tell you to factor something like, let's do this. 5x cubed minus 25x squared a plus 15 x squared a cubed. Right? And I want you to factor that. So that feels like a very different thing. To be honest, it's exactly the same thing, and I'll show you that with an easier example in a minute. But this is really a form of the most basic factoring. Oh, there's everybody. Here, let me do this so you don't freak out. I gotta hit one more button. All right, sorry. The little dude's looking at you. Does somebody remember this form of factoring here? This is the most basic form of factoring. Real quick, watch this. Oh shit, I got so many wires up here. How would you do this? How would you simplify this? Yes, good. And what's that called?
Oh.
You remember?
I don't know what it's called.
I'm sorry. All right. So it's called distributive property. So sometimes math people call things good names. Because what are we doing with the two? We're distributing it. What am I doubling? Both of these, right? So how do I do it? I double both of them. So what I'm asking you to do here is the opposite of that. What can you pull back out? So really, this factoring is just undistribution. What number did all of these things get? 5. You guys see that? So I can pull a 5 back out. How many x's do they all share? Like, how many x's does this dude have?
3.
That's nice for him, because this guy's only got 2. So if you're going to be like the fair tax man, you're not going to take more than somebody has, right? Could I take 3 x's away from him? Yes. Could I take 3 x's away from him? No. So how many are you going to take out? 2. So you always take out the lowest power on a variable that you see, because that's the amount that they all share. So I'm going to take out 2 x's. Can I take out any a's? Do they all share some number of a's? No, because the first dude doesn't have a's, right? Poor little dude. So I can't take any a's out. Okay, how are we all feeling right now?
Good.
Some of you guys will look at me like, please start making sense. Does this? And some of you guys, I understand. Some of you guys are like, what the shit's this? This is easy. Great. Sit there and enjoy that. Well, you can. All right? Okay. So then the question becomes, what's left if I take that stuff out? Well, then you go term by term. I took the 5 away, it's gone. I had 3 x's, I took 2, so how many's left? 1. I had a 25, I took out 5 from that, divided 5 away, so what's left? 5. Had 2 x's, took them. Had an A, didn't take any A's, still got an A. Had 15, divided by 5 out. 3. Had 2 x's, took them. Had 3 A's, took no A's, still have all the A's. Right? Anybody remember what that form of factoring is actually called? It's not called undistribution. Starts with a G.
Oh. Greatest common factor?
Greatest common factor, GCF, right? It's the biggest thing you were able to take out of all the pieces. How is everyone doing? Okay, so again, real quick, just to let you guys know, I completely understand some of you just came out of algebra in high school. This is all easy shit so far, great. Some of you have not had any math for years. Is this true? Yes. So I've got to find a balance because we got to keep it going forward, but I also want everybody to be on the same page. This is where, if it's true that either it's been forever since you had math, or you currently don't know what the hell I'm talking about, you need to go see some tutoring. And actually, later today, we're going to take our field trip, and we're going to go see where the tutoring center is, where my office is. Okay, everybody with? Please, dear God, if you have a question, at least 8 other people have the same question. You're not alone. Ask it, right? I like to say, if I'm going too fast, slow me down. If I'm going too slow, deal with it. You guys hold with me? Some of you guys look like, I don't understand anything you're saying. Okay, so that's this. Yes?
Why are the parentheses there? Is it just to kind of separate the x's?
How would I go back? Like, what would I do here to go back?
Okay.
Wouldn't I multiply these together? So how would I go back here? I would have multiplied these together. The parentheses means this is in front of all that.
Okay.
I would distribute.
Got it.
Whatever I do to anything, I have to be able to go back, right? So if I factored 42 and what I got didn't become 42 again, I did something wrong. So whatever I get, better multiply back out to be what it started off as. Does that make sense? So how do you check a factoring problem? Multiply it back out, right? You can do that with any factoring problem. Okay. Do you guys agree? You guys all know what FOIL is? I don't mean you wrap a potato in it, put it in the oven, right? What's the math FOIL? Do you guys know? If you don't know, I'm actually kind of happy. You guys have heard of foiling things out? Yes?
Outward.
A minus C, A minus B.
Yeah, first, outer, inner, last. Okay. I'm going to say something you haven't heard many math people say. That's absolute bullshit. It makes it feel like I need help to do this, but really, let's do this. Before I get into full factoring, let's do the other way around. How would you simplify? Don't say anything. Take a minute and think about this. Do answer this question. What's the operation happening up there between those two things? Multiplication, because they're sitting next to each other, right? There's no symbol between them. It must be multiplying. Now, don't say anything. Try to simplify that. Try to do what you just said. Try to multiply those. Right? Give it a try. Now's the time to make mistakes, because I'm not going to look at your work. Get the mistakes out the way. If you don't know what to do, just draw a duck. Make it look like you. No, actually do this. It's a better idea. Had somebody show me their duck drawing when they said that one time. All right, who thinks they have this going the right direction? What are you doing?
What do you want the answer?
Just tell me what you did.
Oh, I multiplied x with x, the negative 4 with 5.
Oh, and that was it?
No.
Okay.
And then the x was 5 again.
Okay. And then the negative 4 of the x?
Yeah.
Okay, so here's a suggestion to keep things, because remember, this thing can get bigger, right? And I have to do 2 times 2. I can do 2 terms times 8 terms, right? So I don't need FOIL. FOIL is crap. All it is repeated distribution. The x gets a turn. right? The x distributes. Then the -4 gets a turn, right? Okay. And again, I see some faces. Some of you guys are like, holy crap, this is easy. Great. Enjoy it. I want everybody on the same page. And then the -4 gets a turn. -4 times x, -4 times 5. Okay. Yes?
So then, in turn, the box method can also.
Box method works, but again, I think it's just extra work. I think it's extra to draw a box and put all the crap. No, just, we all of you, and I know some of you guys were looking at me like I was insane, but maybe, I don't know. You all should be able to distribute without any help. Right? What would this be? XY plus 3y. Okay, now do y'all notice that I just did that, and then I did that? Right? Okay, you guys with me? And FOIL is like first, outer, inner, last. I don't need that. I know how to distribute. I'm just going to do it twice. Whoop-de-doo, right? If there were 3 things in here, I would do it 3 times. So I don't like FOIL. I call it repeated distribution. Are you guys all with me? So since we're about to talk about factoring, it's not a bad idea for me to take a second and make sure we all know how to multiply these things, because factoring is undoing that. If you figure out how to do this, factoring is going to make even less sense. Are we all good? Okay. Let me show you one little thing. Well, first off, are we done? Really?
Yeah.
You sure?
No.
Oh.
I like it. Some of you guys are like, oh yeah, I'm done, man. I don't care. I'm done. Whatever. All right. One thing that you guys might not be able to see much, and your teachers might not have shown you this. What can x be? In general, like what can x be?
1.
It could be 1. What else could it be?
0.
0. 2. So tell me everything it could be.
Anything.
Any real number.
Infinite.
Yes?
Yeah.
Are you guys with me?
Yeah.
It can be any freaking real number, right? So let's start fresh. Give me a number that x is. Tell me what x is.
2.
Let's do 3. I think this is the first number I heard, right? So now just go with me for a second. This is extra shit, yes? This is extra. This is me being teacher, doing teacher shit. You never have to do what I'm about to do, ever. That problem is done, yay. If x is 3, can somebody tell me what that number is? -1. And what's this number? 8. And what's -1 times 8? Holy shit. Now, if x is 3, how do these two things relate? Not if x is, but just in general. How does this relate to this? They are equal, yes? Because we worked with this and we made it look like that. These two things are equal. So if I make x 3 here, it better freaking equal -8, right? 3 squared plus 3. So what's 3 squared? 9 plus 3? 12. 12 minus 20? -8. Okay, cool, right? That's the concrete behind the scenes thing of what we just did. Algebra is abstract because I really want you to really fully take this in. When we did this, we multiplied an infinite number of numbers together. Do you understand what I mean? Because what could x be? Anything. We made it 3. Could it have been 7?
Yeah.
Could it have been 5.18? Could it have been the square root of 111? Sure, it could be whatever the shit, right? You guys understand what I'm saying? So that's why, of course, algebra is going to be a little hard because you're actually doing an infinite number of things. So you can say to your friends, what did you do today? I don't know, said, well, I did an infinite number of multiplications. Holy shit. All right. I don't know if that would be impressive or not. I think probably. Are you guys semi with me so far? Okay. So, let me see. I just kind of got to feel out where you guys are. I probably should have brought more with me, but that's okay. Okay, so this is how to multiply things together. Now what we're about to talk about is how do I go backwards, right? Which is the equivalent of taking 42, making it 6 times 7, but going backwards, right? That's going backwards, it's factoring it back out. What have I done with my, did I put it up here? Yes, I did. Forget these things are magnetic. So let's start with a relatively nice one. Let's see if anybody remembers how to do this. Okay. So I want to factor this. right? Yes.
I would do the x squared.
What
Or
about?
the x method, sorry.
Oh, this thing.
Yeah.
Oh, sure, whatever. Sorry. I never fully. Does everybody understand this one? What would it be? What would you put up here?
Eight.
8, and what would we put here?
6.
6. So you need two numbers that multiply 8, add to be 6, right?
Yeah.
As a math teacher, whatever makes it make sense is great. Personally, I don't know what putting this x does, the magic it does, because the question doesn't change. The question is, I need two numbers that multiply to be 8, and they also must add to be 6. Now, I think all of you guys, that could have been a question that was asked to you in like 6th grade, right? So give me two numbers that multiply to 8, and they add to be 6.
4 and 2.
4 and 2. 2 and 4. Give me two things that multiply to be x squared. X times x. So that the beginning of it is always known, right? When there's a 1 out here, it's always going to be x and x. What's unknown is what the numbers that go here that make these happen, right? You guys with me,
Yes.
sort of?
Yeah.
So if I put a 4 and a 2, wouldn't that be 8 when I do that? And wouldn't that be 6x when I do those and combine them? You guys see that? That's why a trinomial, oh shit, 3-term dude, trinomial, that's why it boils down to finding things that multiply to be something and also add to be something. It becomes a number puzzle, right? I know some of us are like, I don't give a shit about a number puzzle. I understand. So then, of course, the signs have to be plus and plus to make that become plus, right? Does this sound familiar at all?
Yes.
Does this feel familiar? No.
Yeah.
No, okay. I'll tell you this. I've got worksheets that I gave to my intermediate algebra class. They're called factoring motivation sheets. So real quick, let's do this. I'm gonna do a few quick fire multiplications out. Just follow with me, okay? So like if I have x plus 5, x plus 6. If I multiply these out, I get x squared plus 5x plus 6x is 11x. 5 times 6 is 30. I'm going to do this a little quickly, but you guys know how to FOIL now. Not a big deal. You guys with me? Where'd 30 come from?
5 and 6.
5 times 6. Where'd 11 come from? 5 plus 6. Two numbers that multiply to be the last dude and add to be the middle dude. Why do we look for those? Because that's how the shit that happens. That's it, right? Most of math is doing math stuff and going, is there a pattern as to what always happens? Yes, this number is always the product of those. This number is always the sum of those when there's a 1 out front, right? Okay. Let's do another. X minus 4, x plus 11. So I get x squared plus 11x minus 4x minus 44. Where'd the negative 44 come from? Negative 4 times 11. Where'd the 7 come from? Negative 4 plus 11. And you see how math people would say, I'm not going to do that every damn time because now I see where they come from. I can just make a shortcut out of it.
You're just combining the x's while you're doing it, right?
Yeah, I'm sorry.
Okay.
So I'm kind of skipping that middle step of plus
Okay.
5x plus 6x. And then you combine them. Is that
Okay.
cool? Yeah.
Yeah.
Okay. How are you feeling at the moment? So what that means is we've developed a shortcut as to how to go backwards. So, let me put a fresh problem up here. Let's say x squared minus 4x plus what, Jeff? I don't know. Let's do minus 45. A lot of negatives. Damn it. One thing I know for sure is that this came from two binomials, two little dudes, right? You with me? And what do I know for sure goes at the front?
X.
X and x, because that makes x squared. So that first piece is easy. It's the numbers that are all free. So what? Don't tell me the answer. But what do I need to have happen? I need two numbers that. Okay, I like that. There'll be different signs. How do you know they're different signs?
Because the 45 is negative.
Good. They have to multiply to be negative 45, so I know they're different signs. And they also have to add to be negative 4.
So the bigger number has to be negative.
Say again.
The bigger number has to be
Ooh, yeah. So the bigger number has to be negative so that when I combine them, the answer is negative. Does that make sense? If my debt is bigger than the money I've got, I'm still in debt. That's what I just said, right? Are you guys with me? So two numbers add to be negative, your debt's bigger, the negative number is bigger. Okay. It's always good to bring negative and positive to money because we all deal with money all the day in time. Right? And I remember in college, I was in the negative a lot. So I don't know if you're in the same situation. So, for example, 3 times 15. Isn't 3 times 15, check me, 3 times 15, is that 45? I'll let you trust me. Yes, it is. But there's no way to combine 3 and 15 to get 4, yes? If I make the 3 negative, I get 12. If I make the 15 negative, I get negative 12. What else multiplies to be 45?
5 and negative 9.
Yeah, 5 and 9 makes 45, yes?
Yeah.
And if I make the 9 negative, it also adds to be negative 4. Are you guys following? Okay. So this is the kind of problem where the better your number sense is, the more familiar you are with how numbers kind of like interact, the more you know. For example, it kind of, I'm not saying it's fine, but if I say 8 times 7 and you reach for your calculator, I get concerned. Do you understand what I'm saying? And some of you guys are like, well, you're going to have to deal with that shit. But the more you have to reach for a calculator for that, the harder this kind of problem is going to be. Because the harder it's going to be for you to make a list of things that work here. Yes? It's just the fact. Okay. So what does all this mean? What's the answer?
Negative 9 plus.
So put plus 5, because it's positive, minus 9. How would you check that?
Do it backwards.
Multiply it out. I like it. Kick ass. Okay, I like it. Okay. Now, let's do the same thing we did earlier. Just real quick, this is the last time I'll do this. What could x be? Anything. Somebody give me an x that's like, I don't know. Somebody give me an x that's more than 11.
23.
23. Holy shit, yes, now we're talking. So this problem is done, right? Well, Jim Carrey would freak out. I don't know if anybody gets that right. X can be anything. This problem is done. We're about to do extra weird shit. You don't have to do this. If x was 23, help me out. I'm going to need some help. Maybe I won't. Let's see. I put a 23 in for x. 23 squared, let me see real quick. Hold on. 23 squared would be 529. Check me. Yes? Okay. 529 minus 4 times 23 is 92. Minus 45. Is everybody understanding what I'm doing right now?
Mm-hmm.
This expression is here. X can be anything. So we just made it 23. I could have made it anything. If I put a 23 in, I get whatever the shit that is. 437, 398, maybe? Can somebody help me? Let's see. Minus 137,
392.
2. Okay, damn it. It's a little early. Okay. Everybody with me so far? Extra shit. If x was 23, this expression would represent this number. Yes, that's what that means. What is this number then if x is 23? Right here. What is this if x is 23? 28. What's this if x is 23? That's right, kids, 14. Okay. What is 28 times 14? Does everybody have a calculator? No? 392. Of course it is, because these are the same stupid number. This is just the number before it's factored. This is the number after this. Whatever the hell you pick for x. Why would 9 be a silly one to pick, sort of? Because it would make the answer
Oh.
0. But then you could check it. Figure out what makes it 0 and plug a 9 in and see if it does equal 0. That'll tell you, hey, it looks like you got this right. Are you guys at all with me? A little bit. Okay, how you guys feeling? Everybody feeling? Less of you have this look like, what the shit? Okay, which makes me feel better. Now again, if you're still in the what the shit phase, see me in my office hours, see tutors, right? Okay. So, let's see. Let's do another one real quick, and then we'll build up to the first problem on the sheet there. We're not even there yet. So you guys, real quick, try this one out. Don't say anything. Crap, I don't know. Plus, sure, minus, sure, okay. It's not too crazy. Don't say anything, just try that out. Yeah, I guess I am, okay. So just turn it off right now. So again, if the big X works to make it easier, use it. If you don't know what the big X is, great. I don't understand what it does, to be honest. Somehow it does magic. Because the question doesn't change. The question is still two numbers that multiply by negative 30 and add to be 7. So what'd you guys get?
-3 and 10.
If I do, negative 3 and 10, I do get positive 7. Since this is plus, the bigger one has to be positive. Kick ass. So don't look at it as a bunch of stuff to memorize. Look at it as a bunch of checks and balances. Positive 7. Okay, they better become positive 7 when you add them. Yes?
Does it matter when you put it in the parentheses which number?
I see. What's 6 times 7? She's like, answer my question. What's 6 times 7? 42. What's 7 times 6?
42.
That's commutativity, right? Commutativity. You guys, the commutative property of multiplication. So it doesn't matter.
Okay.
So I could answer this as x minus 3, x plus 10, or I can answer this as x plus 10 times x minus 3. Math didn't give a shit. It's multiplying, who cares? And that's why in PEMDAS, I write it like this, because if I'm all on this level, it doesn't matter. Well, if I'm all in there, I should say, if I'm on a single level, it doesn't matter which way you order things, right? Now, I just did something horrible. It does matter between these, but if I'm in a single operation, like multiplication, it doesn't matter how you do things, right? For addition and multiplication. Does that work for subtraction, for example? Does it matter which way I do subtraction?
It does.
Shit, yeah. What about division?
Yes.
Yes, okay. So it's only multiplication and addition that doesn't care. Okay. And you can do the same. I'm not going to do it again, but you can pick a number for x. You can figure out what number this is. You can figure out what number these are, and you can see that, yes, they do multiply to be the thing. You can try it on your own. Doesn't matter what number you pick. What number would make this 0?
0.
No, 0 would make it negative 30. See that? What number would make this 0? We can answer that very quickly here. What number makes this 0?
3.
So 3 would make this 0, because 0 times who cares is 0, yes? What other number would make this 0? 10 would not make it 0. Negative 10. You guys with me? So I don't know if you guys remember, you would factor stuff. If it was an equation, then your answers would be 3 and negative 10, because that's what would make it 0, right? That's all you're doing is if you're breaking it down to parts, if any part is 0, the whole damn thing is 0, of course, right? Does that make sense? So then if I see the parts, I can see the answers damn quick. If I just look at this, I don't know what the shit makes that 0. But if I break it to its parts, easy. How we doing? All right. I'm getting more and more of you with better looks on your faces. Okay, I like that. All right, okay. Now, that first problem on number 3, what's different about it than any problem we've done so far? There's one major thing different.
There's no greatest common factor.
Okay, there's no greatest common factor for anything we've done. There's no GCF here, right?
Sure.
All right,
Oh,
now.
there's a number in front of the x.
Shit! There's a 4 in front, right? You guys with me? Why were these easy? Because what's the only thing that I could have put here? X and X. If there was an 8 here, couldn't this have been 8 and 1? Couldn't it have been 4 and 2? Oh, shit, right? You guys with me? So it gets a little harder when that first number is not a 1. You wish you could take it out. If it was a GCF and you could take it out, great, because then you could just do this shit, right? Without a number there. Okay, so, sorry. I just remember one semester somebody got upset at me because I sometimes cuss, and I'm like, oh shit, not too bad. So if I offend you, just wait a few minutes, I'll do it again. So let's do this. I'm gonna do another example backwards. We're gonna multiply something out. Can somebody help me out? If I put, what would make the first number, I don't know. Let me just say this. I wouldn't just want x and x here, right? To have the first number be something other than 1. So I could put maybe, let's say 2 and 3. Now it's gonna be 6x squared, blah, 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 right? You guys with me? And let's just keep everything positive for the moment as we step into this new weird shit here. Okay. Take a minute and FOIL it out, multiply that out. I'll wait. Gotta keep an eye on the time. Oh, this clock doesn't work either. Oh shit, maybe it does. It just went like 5 seconds forward at once. Is that clock right?
It's 9:54.
I swear to God. Okay. Oh, yes. Okay, that clock's right. Watch it. Watch it.
That is so weird.
Wait. Okay, sorry. So we exist in 5-second increments, just so you know. I'm sorry. Keep going. We have an AC that works and a clock that mostly works. That's pretty damn good. All right, guys, so help me out. What does this become?
6x squared. Do you want them separated or
Yeah.
together? 8x.
8x.
And then 15x.
15x.
And then 20.
20. So then you get 6x squared plus 23x plus 20. Now, remember, real quick, that 20 still comes from the same place, doesn't it? Where'd that 20 come from?
The 5 and 4.
5 times 4. Does the 23 still come from the same place? 5 plus 4? Is that 23?
No.
That would be neat. That would be freaking. All right. You guys with me? So I really want you to understand what just happened. I put a number in front of both. Of course that's going to mess up the middle term because that first number becomes a part of the middle term when I do this and this, right? The 8, the 2 messed with the 4, and the 3 messed with the 5. Oh, shit. Okay. But I want to show you something kind of cool. What is 8 times 15? Did anybody bring calculators? No.
I'm waiting for it in the mail.
Say again? 120. I like it. What is 6 times 20? 120. We're going to use this to our advantage. Remember the way we just did it earlier? We saw a pattern and then we made a shortcut out of it, correct?
No.
That's why people say math is all about patterns. That's where all of our processes come from. We just notice things and go, oh, there's a shortcut. Right? I like it. So that's why your job is so hard as a student, because you got to catch up with all the shortcut weird shit that we came up with. You got to catch up with that. And we're all like, well, yeah, we keep with you. All right. Let's try another one. Let's put some negatives in there, see what happens. I don't know. Sure. So that's a little different. I just have my favorite numbers of the day. So if I FOIL this out, I'll get 8x squared plus 20x minus 6. I should have picked different numbers. Damn it. It's all right, John. Minus 15. Yeah, it's the same stupid numbers, John. Damn it. But the same thing happens again. I know this is not done, correct? But what is 20 times 6? 120. What's 8? Negative, sorry. Times negative 15. Negative 120 again, right? Let me do one more with some different numbers this time. And of course, you would finish it out. I can do it. 6x plus 2. No, let's make it 5. 4x minus 7. I'm really sorry for you guys over there. Can you see it okay? I love long roots, but I won't. 24x squared minus 42x plus 20x minus 35. Is that cool? I'm going a little fast, but just watch. What is 24 times 35? Anybody? 24 times 35.
840. Negative 840.
Negative 840, I like it. What is negative 42 times 20? Well, twice 42 is 84. Add a 0, 840, right? So now I'm showing you all the little nitty-gritty details. Now we can try to make a shortcut off of this. So here's what we do. If I have a problem, I'm going to go to one of my standards. I know this one works. If I have a problem, the very first thing I have to do, see how the freaking first numbers came in and messed shit up? So I have to take them into account. No longer does, so 5 times negative 7 is negative 35, but 5 minus 7 is not negative 22. I mean, so the middle term doesn't work right. Why not? Because it got all messed up. So the first thing I do is I take this number times this number. And then it's the same steps. I bring the 4 into account. What two numbers, now it's the same. What two numbers multiply to be negative 24 and add to be negative 5? I need two numbers that multiply to be negative 24 and add to negative 5. 8 and 3. Which one's negative to make it negative 5? Negative 8. Now here's the problem. Those aren't the numbers that are going to show up at the end. Those are the numbers that would show up here, for example. I'll show you when I do this out again. So what do I do then? What was the step right before we got to the end here? Do you see the step right before the end? There's 4 terms.
Yeah. Combine the middle two.
So what I'm going to do is I'm going to break the middle two apart. I'm going to do everything there backwards. So I'm going to take this number. I'm going to leave this one alone. I'm going to leave this one alone, and I'm going to break this up. How? Minus 8x plus 3x. Did I just, are these two still equal to each other? That's the same problem, correct? So that's totally legal. Normally that wouldn't make sense to do that, but who remembers what to do when you have 4 terms? Group. What comes out of these two? What number comes out of those two? Careful. Just a 4.
4x.
Yes, and an x, right? They both have an x. Are you guys with me?
Mm-hmm.
So now you kind of look at this as 2 different problems. 4x comes out. What's left? The 4 is gone. I have 1x left minus, careful, 2. Plus, what comes out of these two?
3x.
Now, real quick. Okay. Some weird shit. So when you have a number out front that's not 1, you multiply that with the last dude, do the same steps, but then you break the middle term up, make it 4 terms. 4 terms means grouping. Grouping should be relatively easy. How do I know I'm on the right track? These are the same. Real quick side note. 4xb plus 3b. How would you factor that? What can you take out?
B.
Why can you take a b out?
There's 2.
Because they both have a freaking b, Jeff, right? So you can take a b out. Okay. So what do they both have now?
Negative 2.
No.
Oh, x.
Minus 2.
Oh.
This first term has a 4, an x, and an x minus 2. I don't see a negative 2 anywhere in there. Does anybody think I'm insane? Because you're all like, Jeff, man. There's a negative. No. I see an x minus 2. That's a number. If x is 7, that is the number 5. Is there a negative 2? No, it's freaking 5, right? Did I say negative? they both have an x minus 2. So just like the b, do you see how now the b became x minus 2 here? So it can just come out. Does that look familiar to anybody? Some of you guys? Okay. Does it make like even just a little smidge of sense?
Yes.
Maybe some of you guys a little more than a smidge? Okay, I'll keep it as a smidge.
So the second, the second parentheses section, like the 4x plus 3, is the remaining?
If you take an x, just like you had a 4x plus 3 here, if you take an x minus 2 out, 4x, x minus 2 out, plus 3.
Okay.
Yeah. You can literally just cover what you took out and write what's left. Watch this. Remember these two numbers? What's negative 2 times 4?
Negative 8.
And what's 1 times 3? All right, so those two numbers, they are what the middle terms would be. And again, you don't have to know that, but it's just part of why the pattern works. Okay, maybe? So you guys take a minute. Let me, here, wake back up, little dude. Do number 3A. See if you could do number 3A. Of course, as any good math teacher, that is a harder problem than... Oh, did you not get this? This is from yesterday.
Oh.
Do you have it? Okay. This is my last. This is my last sheet. Don't take it. And again, I don't want to freak anybody out, but factoring is stupid important. It's not going to be everywhere, but it's going to be everywhere. I don't know if you quite understand what I mean. It can show up anytime it wants to, and it's going to show up a lot. So the better you understand it now, the better time you're going to have.
My calculator's not like in the mail yet. Can I use my phone for now?
Yeah, of course. Yeah. Can't use a phone or a quiz or a test, but
Oh.
I don't care if we don't have that happening. Who cares? Uh-oh. Poor little dude. Are you stuck again? I love it.
The camera's off the board.
Oh yeah, thank you. Anytime you see that, I will gladly accept that kind of correction. Let's see, what's the power? You're the power. Everything almost works. I love it. Okay. What time is it? Oh, interesting. Okay. Come on, little dude. All right. Oh, crap. You can do it. There you go. So let me catch up to you guys. What's the first thing you're doing? 4 times negative 10 is negative 40. So I need two numbers that multiply to negative 40 add to be negative 3. I like it. So you get 8 and 5, and the 8's got to be negative to make it come out negative at the end. Is that cool? Huh?
That's as far as I got.
All right. So then you take the middle term, and you break it up. So you get 4x squared minus 8x, right? So these two are basically the coefficients of the middle term. You understand? Whatever you write down here has to work back to be what you started with, or else you just made a new problem. And I don't like that. You can't be like, Jeff, I don't like your problem. I'm going to make a new one. Yeah.
We did 3x instead of 5x.
Of course I did.
Okay, I was just wrong.
Thank you. As I talk, I can't keep up with what I'm writing. Now what can I do? Now that I've made this 4 terms, I can do what? I can group it. right? Notice something real quick. Don't drop parentheses in. Just underline the two things. Because when you drop parentheses, if there's a minus in the middle, everything gets freaked out. Do you notice how I've done this? Anytime I could, I put the negative first. Because if there's a minus sign here, it will screw you up. So what comes out of the first two? 4x. And what's left?
X minus 2.
X minus 2. What comes out of the next two?
Plus 5, and then X minus 2.
If these two are not the same, you've made a mistake or it's not factorable. More likely you made a mistake. But some of these things could be prime. There will be some problems where it just won't factor.
So why do you put the negative first?
I'll show you. We'll do the same problem again, but I'll do them the other direction, right? And then the last step would be, what can you take out?
4x plus 5.
All right, so you can put that first, and the x minus 2 comes out. You can put them either order, right? Because multiplication doesn't matter. Somebody with that? So let me do this. Somebody got that? I'm going to do this the other way. Do I have a whole lot? I do. Okay, good. So I'm just going to screw you guys. All right. What if I would have written it like this instead? Most interesting. So all I did was I wrote these the other way, right? So I'll show you what people do. So I can take an x out of here. What happens very often is people will do something like, they'll take a negative 8, Jeff, good job. Negative 2 out, and then they'll do this, 4x minus 5. What mistake? Did I just make a mistake?
Yeah.
Because what did I actually take out? A negative 2. So that should become positive, and that should become positive. But do you see how easy it is to make that mistake? And then what I really love is when these are not the same, somehow they take the next step. The next step is impossible unless they both have something you can take out. Does that make sense? So if these two are not the same, something went wrong. The most common mistake is a sign mistake. Now I can do x minus 2 times 4x plus 5. Notice one little thing. Over here, the 4x plus 5 is on the outside. Do you see that? Over here, the 4x plus 5 is on the inside. Here, the x minus 2 is on the inside. Here, the x minus 2 is on the outside. Okay.
Oh.
But it ends up in the same place, correct?
So it's still like a correct way to do it, right?
Say again?
It's like still the correct way to do it.
Either way works. Just if you have a choice, I put the minus first so you don't make a negative mistake. But either way works. I love it. Kick in the acid. So, for example, if I said factor 42, and you guys said 6 times 7, what if somebody else said 2 times 21? Are they wrong? No. If you keep going, Jeff, you both are going to end up in the same place, right? So who cares what happens in the middle as long as you end up at the same place at the end? Okay, maybe. Okay, I like it. Okay, that's the first problem. What about part B? So let me do an easier example of part B. Does anyone know how to factor x squared minus 25? Yes. X minus 5? Yeah. Why does that work? What's the middle term? Is there a middle term?
No. Well, it's a 0.
0. So I can still do two numbers that multiply negative 25 and add to be 0. So don't they just have to be the same number, different signs? So then I just make a shortcut out of it. X squared, x times x. 25, 5 times 5. Minus, plus, done. So this is called the difference of squares. And it's what I call a thank God or a thank your favorite deity, the god of coffee, flying spaghetti monster, whatever you enjoy. But you should sit there and say, thank this deity, because any difference of squares problem is easy as shit. I don't care how big it is. So all I do for a difference of squares problem, I cut each thing in half. What's 4x squared cut in half? 2x. 2x. What's 9a4 cut in half? You can do it. And when I say cut in half, I mean multiplicatively. So what's 9? 3 times 3, yes? And what's a4 cut in half? A squared. There. Minus plus or plus minus. Done. Any difference of squares. When you see them two terms, minus in the middle, everything squared. It's easy no matter what. So let me see if you guys still agree with me when I put this next. I'm going to make another problem up. Do I have paper somewhere? No, Jeff, no. Oh, you sort of do. What is this shit? I don't know. Here. You ready? All right, here it comes. You ready? 49, A10, B14, C28, minus. What do you got, Jeff? 144, X28, Y8, Z100. Right? And you're all like, dude. And I'll be like, Yoda, size matters not. Right? Who gives a shit? How many terms are up there? How many terms are there? 2. 1, 2. Right?
Oh.
Is there a minus in the middle?
Yes.
Can you cut everything in half?
Yeah.
Easy. You cut everything in half and you're
Yes.
done, right? All right. I need some big suckers here now, right? 49, 7, A10, cut in half, A5, B14, B7, C28, 14. Then write the same thing over there, because together they'll make a whole one, right? Do you guys understand? If I cut it in half and put it in 2, when I put them together, I get the original. That's almost too nice to believe. Minus, plus, 144. What times what is 144? 12. 12. X28, that'd be X14. Y8 would be Y4. Z100? Half of that is? Z50. X14, Y4, Z50. So, mathematical processes don't give a shit what there is. So there's a process for difference of squares. As humans, we go, oh my God, it's a lot of crap. Math says, do everything in half, minus plus, go to the next one, right? It doesn't, do you guys understand? So a lot of you guys give up on a problem that's got a lot of stuff in it, but it just has a lot of stuff in it. It's just more to write. The process doesn't change. Maybe? No?
Yeah.
Do you see how we designed it? So if I multiply this by this, of course I get this. We designed it to work that way.
Yeah.
Minus whatever the shit that is, plus whatever the shit that is. So who cares what the shit that is? Because it cancels. We made it that way. And then when you multiply this times this, you get the whole thing. Okay. Maybe? Maybe. Oh shit, where am I? Oh shit. I wrote over the, oh shit. All right, I need more space somewhere. That's this guy. Good. Then this last guy. Okay, what time is it? I got to give us enough time for this little field trip. I think I can do this, and then we can go on our little field trip. Okay. Maybe. Hues are everybody's favorite problem. Has anybody ever seen the movie Pulp Fiction?
Such a good one.
If you haven't, that's not a prereq. Don't worry, you're okay. But there's a part of this that I relate to the movie Pulp Fiction, right? Real quick. This should be an easy one. How do you factor this?
X plus 2.
Yeah.
And X minus 2.
Bam. That's easy shit. 2 terms, minus in the middle. You can cut everything in half, so then you do it. What's different about this problem? Is there 2 terms? Is there a minus in the middle? Can you cut everything in half? No, not multiplicatively. Right? What times itself is 8? Bless you. What times itself is 8? Huh? Square root of 8. Uh-huh. No, but so we don't know what number that is, right? You can't tell me. Are you kind of with? So, but I can cut everything into thirds, can't I? So here's how this works. You put a little dude and a big dude, and you'll see why in a minute. So when you see a cube, you put a little dude and a big dude. What did we do up here? We actually did this, didn't we? We cut everything in half. Didn't we cut everything in half and put one there and one there, one there and one there? Didn't we do that? So now we're going to cut everything in thirds. X times X times X. What's 8? 2 times 2 times 2. The little dude. You can just put 1. You take 1x minus 1, 2. So what goes here then are the other two x's. When I multiply this out, don't I get 3? What goes over here is the other two 2's. When I multiply this out, don't I get minus 8? So why do I still have room in the middle? Why don't I just stop? Because don't we also get minus 2x squared? Do we want minus 2x squared? Is it part of the problem? So this is so far wrong. We are wrong because we have an extra thing. Don't we also get plus 4x? Do I want plus 4x? Is that part of the problem? No. So I need to kill those somehow. So do you guys remember the scene? Guy in the back seat, gun flopping around. Bad things happen. Mess in the back seat. They got to call the cleaner. I think his name was the Wolf. Right? Again, you don't have to know Pulp Fiction. You really don't. So what this guy's job is to clean this shit up. And I've appropriately put it in blood red, but anyway, sorry. Didn't even mean to do that. So this guy's job, I need something here that will create minus 4x and it will create positive 2x squared, because then those are canceled. So what will always work is these two opposite signs. Watch what I get. Minus 2 times 2x. What's that? Negative 2 times 2x? Negative 2 times 2x. Negative 4x cancels. What is x times 2x? 2x, x times 2x. Squared cancels. So this guy's job is to kill the extra shit you got that you didn't want. So watch. 1 of each, 2 of each, product in the middle. That's how cubes work. And that's why people don't like, and of course, that's facing the wrong way again. Damn it. Don't worry, it's my fault. I need to hire somebody. Hopefully it's gonna do. Anyway, we'll do more of this next time, but I think I need to get us going on this field trip so we have time.
That's a good question.
So, do this for me. Pack up, walk out the door, go that way a little bit, and wait. Yes? Go out the door, go that way, and wait for me. Okay. I gotta catch up.